I'm Brittney Byrd. I'm in Math 1073-16. I'm doing problem number 34 in section 5.6 on page 395. So the problem is x to the third plus 13x squared plus 57 plus 85. So since you have an exponent to the third, you either have 3 real zeros or you have 1 real zero and 2 complex zeros. So first you look at the signs. Since you have positive all throughout and there's no changing of the signs, you do not have any positive zeros. So now we do Descartes' rule of signs. So you take the ones that have an odd coefficient and you change this is an x. You take the ones that have an odd coefficient and you change the signs of those. So since this is x to the third and this is x to the first power, you change the signs of these two. So this is negative x to the third plus 13x squared. This one doesn't change. This one does change to a negative, and then this one doesn't change. Now you have 3 changes of signs here, from negative to positive, back to negative. 1, 2, 3. So you have 3 negative zeros as your answer, which will make sense because you can only have 3 zeros. So of those, either 3 of them will be real, or 1 will be real, and 2 will be complex. So then the next step is you use the rational zeros theorem. So you take this number here, 85, divided by the coefficient here, which is 1, and you find the factors of each, and it's also positive and negative of the factors. The factors of 1 are 1. The factors of 85 are 1, 5, 17, and 85, all which are positive and negative. So then, 1 over 1 is positive and negative 1, 5 over 1 is positive and negative 5, 17 over 1, positive, negative 17, and positive and negative 85. Now you take these coefficients and you try synthetic division with them to get, if you get a 0, then that means that you find the 0. So you take the coefficients here, so you have 1, 13, 57, and 85. You do synthetic division. I'm going to start with negative 1. You bring this number down, which is 1. Negative 1 times 1 is negative 1. 13 plus negative 1 is 12. Negative 1 times 12 is negative 12. 57 plus a negative 12 equals 45. Then you take negative 1 times 45 is negative 45. You add these two, you get 40. Since this is not equal 0, negative 1 is not a 0. So now I'll try negative 5. So negative 5, 1, 13, 57, and 85. Bring this down. Negative 5 times 1 is negative 5. 13 plus negative 5 is 8. Negative 5 times 8 is negative 40. 57 plus negative 40 is 17. Negative 5 times 17 is negative 85. You add these two and you get 0. So that means that negative 5 is actually 0 to this equation. So we know that we have 1 real 0. You take this, and now you have a simplified version of the equation, and now this is to the second power, not the third. So this becomes x squared plus 8x plus 17. Since this equation is not factorable, you now use the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So b in this equation is 8 plus the square root of 8 squared minus 4 times a, which is 1, times c, which is 17, all over 2 times 1. And then you also have a minus, because it's plus and minus. So you have negative 8 minus the square root of 8 squared, minus 4 times 1 times 17, all divided by 2 times 1. So you go from this to here. Then you take these two, you simplify it, so you have negative 8 plus, under the radical, you get negative 4, divided by 2. Over here, you get negative 8 minus negative 4, under the radical, divided by 2. Since you can't divide by a negative number, or it will have the square root of a negative number, this becomes an imaginary number. So now you have negative 8 plus 2i divided by 2. This one becomes negative 8 minus 2i divided by 2. To simplify this further, you would just divide each of these by 2. This would therefore be negative 4 plus I. This one would be negative 4 minus I. And then these are the two complex zeros. So your final answer is negative 5 is one real zero, and then you have negative 4 plus I and negative 4 minus I, which are two complex zeros. And since you have it to the power of 3, you can have one real zero and two complex zeros.